Welcome to my first devlog. For this Christmas, I wanted to create something immersive with Three.js. I got the inspiration from internet and decided to create a story canvas to show the life of Jesus with neon lights. With that concept in my mind, setting up the development environment was the first step. I chose Vite, React, and JavaScript for their flexibility and performance, especially when working with a project involving real time rendering and 3D models. Vite is light and performant. For styling, I decided to go with SCSS, which makes it easier to manage complex style sheets. Once all the tools were set up and localhost was running, it was time to lay the groundwork for this project. I began by creating the basic structure for a simple Hello World project, like setting up clean template and implementing some default styles to get the DOM elements looking organized and functional. Next, I gathered all the assets I would need: audio files, textures, and other resources I had collected for this project on my PC, and added them to the codebase. Organizing these assets early on is important for maintaining a smooth workflow later. With the assets in place, it was time to set up the canvas. Before diving any deeper, I wanted to test the setup by rendering a simple cube. This helped to confirm that all the dependencies were working as expected. It's a small step, but it's always good to verify the foundation before moving forward. As everything was running smoothly, I moved on to setting up the gate. It's a habit I always stick to, as it ensures every piece of the work is tracked, reversible, and collaborative if needed. I created the repository for this project and named it Neon Christmas. Now, here's something a bit unconventional. Instead of the usual main or master branch, I named the primary branch Jesus. Why Jesus? Well, why not? With kit setup and branches ready, I was all set to build the experience. After setting up the basics, the next step was to ensure the project was optimized for different screen sizes. I adjusted the pixel ratio and moved on to adding background to the scene. Now it was time to start testing out 3D model in the scene. I opened Blender and created a simple Bezier curve. I wanted something basic to use as a placeholder while I tested the rendering setup. To refine the curve, I added a bevel, giving it a smooth rounded edge. Then I increased the resolution to ensure the shape would appear smoother in the scene. This small, simple model was perfect test object. Simple enough not to distract from technical aspects, but still useful for checking that everything is rendering properly. When it came time to render the Bezier curve into the scene, I knew I needed to keep the project organized as it started to grow. So I decided to leverage React's component structure. This approach not only keeps things neat and manageable, but also makes it easier to scale the project as more elements are added to the scene over time. However, when I initially added the curve to the scene, something was off. It was completely dark, and that's because primitive shapes like the curve I was using don't have any lighting by default. To solve this, I added lights to the scene. I set the material for curve model to my standard material. This material allows the object to reflect and absorb light, giving it more natural appearance. To achieve the glowing effect I was aiming for, I added emissiveness to curve's material and adjusted the emission intensity. Now it was time to bring that signature neon glow to the curve. The post-processing effect were a simple solution for this. Specifically, I added a bloom effect. This softens the light around bright objects and make the scene feel more vibrant and atmospheric. All these adjustments came together beautifully, giving the scene a distant and glowing appearance. As the scene began to take the shape, I realized that The composition needed a little more structure to make it feel more complete. To improve the overall balance, I decided to add a backdrop. This would serve as a frame for the scene, helping to focus attention on the main element while also creating a sense of depth. But it wasn't just about the background. I also wanted to give the scene grounded feel, so I added a reflective ground. The reflective surface helped anchor the 3D object, giving them a sense of place and realism. It also created an interesting visual effect as the neon glow from the curve reflected off the ground, enhancing the overall aesthetics. After that, I made some final tweaks to material properties. This is where the real magic happens. Adjusting things like the roughness, reflectivity, and other material settings to get the exact look I wanted. The combination of backdrop, reflective ground, and fine tuned materials was taking me closer and closer to the final render. To add even more depth and atmosphere to the scene, I decided to add fog. Fog can completely transform the mood of 3D environment by softening distant object. It also helps to emphasize the lighting and glow effect by adding subtle diffusion of light, making the neon glow even more pronounced. After a lot and lots of tweak and changing default numbers, I was finally happy with the way the scene was looking. Next, I wanted to improve scene's interactivity and depth. And what else can give it more of a 3D look apart from adding parallax effect? Parallax is a powerful technique that creates the illusion of depth by moving the camera in response to user's cursor. As the cursor moves across the screen, the camera shifts accordingly, making the scene feel more dynamic and three-dimensional. I set up the parallax so that when the cursor moves up, the camera moves down, and similarly for left and right. It was simple yet effective way to enhance the visual experience and give the scene more interactivity. While refining the parallax effect, I realized that manually adjusting values could become time consuming and tedious. It was clear that having more interactive real-time way to fine-tune the settings would make things much easier. That's when I decided to integrate Leva, a lightweight library designed to create GUI controls for real-time manipulation. Leva gave me the flexibility to adjust the parallax values dynamically with sliders and controls, making the process of debugging and refining much more efficient. I could instantly see the changes as I moved the sliders, testing different configurations and fine-tuning the settings to get the exact feel I wanted. It was a huge time saver and made the development process much smoother. As the project started to evolve, I realized it was time to organize everything more systematically. I wanted to make sure that as the scene grew, it would remain manageable and scalable. So I took some time to create separate folders for different parts of the project, organizing components, assets, and settings in a way that would keep things tidy and easy to navigate. This new structure made it easier to locate files and ensure the project was streamlined, which is essential for maintaining a clean workflow. With the folder structure in place, I went a step further and integrated Leva controls into individual components. Instead of having a one-size-fits-all control for entire scene, I broke it down so each component had its own set of controls. This way, adjustment could be made more precisely to specific elements, whether it was the parallax effect, lighting, or other properties. This level of granularity not only made the scene easier to maintain, but also gave me more control over fine-tuning each aspect independently. So far so good. With the parallax effect in place and Leva debugging tools fully integrated, the scene started to feel much more interactive and polished. I could now easily tweak the behavior of camera and any other element in real time, making the user experience smoother and more dynamic. The added controls also gave me ability to experiment and make adjustment on the fly, which contributed to making the final result even more refined and engaging. Now that the scene was coming together, it was time to create a 3D model. For this, I opened up the Blender and started with a simple Bezier curve, which would allow me to shape the neon design in a smooth and flexible way. To begin, I set up reference image in Blender to guide the overall shape of model. Using the drawing tool in Blender, I began sketching out the curves. Since this was my first time working with such kind of process, there was quite a bit of trial and error involved. And doing this on a trackpad definitely wasn't ideal. It made precise control a bit more challenging. But after a few attempts, I managed to get basic shapes right. Creating this model involved a fair amount of tweaking and adjustment, but that's the part of creative process. Once the shapes were sketched out, I moved them along z-axis to add depth, giving the model 3D form it needed to feel alive. To enhance the look furthermore and make it resemble neon tubing, I applied bevels to each curve. After finishing the basic shapes, I took a moment to check the vertex and triangle count and realized they were too high, which could lead performance issues, especially as the scene became more complex. To solve this, I used Blender's decimate modifier to reduce the polygon count, lowering the complexity of model without compromising its appearance. The optimization step was crucial to ensure smooth performance and to keep the frame rates high. Once I was satisfied with the model's appearance and performance, I exported it from Blender and imported it into Three.js scene. In the scene, I spent some time adjusting predefined values for the model's position, rotation, and scale. It took a lot of small tweaks to get the placement right, but finally it started looking good. Once the model was in place, it was time to focus on customizing each curve's color. I assigned colors to curves based on their names. Then I turned my attention to floor texture. I headed over to Polyhaven, which is a great resource for free and high quality textures. After browsing through their collection, I found a few textures. I downloaded them and imported them into the scene. The floor needed to complement the glowing neon elements, so finding the right balance was key. Using Leva, I could tweak and test material properties, adjusting settings like reflectivity, roughness, and scale. After experimenting with several options, I finally settled on a texture. After that, I extended the functionality of Leva to enable real-time color adjustment for the neon models. With the base scene complete, it was time to take the visuals to next level by writing some shader code. Shaders are a powerful way to create mesmerizing and dynamic effects in 3D graphics. For the curve material, I decided to introduce a two-color gradient effect. To achieve this, I passed two colors, color A and color B, into shader as uniforms for each curve. I started by working on fragment shader, leaving the vertex shader with its default setting for now. The fragment shader is where the pixel level and color related magic happens, so it was perfect place to focus on blending those two colors. Using mix function, I combined color A and color B to create a smooth gradient transition between them. To make this effect even more dynamic, I added pulsating effect using sine wave. After adding pulsating effect to neon glow, I worked on adding wave effect. I tested both vertical and horizontal waves and finally decided to stick with vertical waves. Shader programming is all about small and iterative changes. Even minor tweaks can have big impact on the final result. It took some time to refine the effect by adjusting parameters, experimenting with timing, and ensuring the transition between colors was smooth and visually pleasing. Adding shader code is always a rewarding step, which adds depth and complexity to any simple project. Returning back to the ground, I experimented with a new texture and made the surface more reflective. The next thing I wanted to implement was mouse interactions. I decided to implement curve distortion effect that would respond to users' mouse movement. To start, I needed to capture the mouse coordinates in real time. Using an event listener for mouse move event, I retrieved the cursor's position and normalized it to the range of canvas. Then I added a raycaster for detection of objects under the cursor. I passed the mouse position as a uniform to shader and started modifying the vertex shader. I adjusted the vertex positions based on the proximity of the mouse to the curve, creating a ripple effect. This distortion gave the impression that neon curves were reacting to the user's interaction. For shader programming, achieving the right balance requires a lot of testing and fine-tuning. I experimented with intensity of the distortion, the area of the effect, and timing to ensure that the interaction felt smooth and responsive. When the implementation was complete, the result was exactly what I had envisioned. This was all about the 3D stuff and shader programming. After this, I added loading state, some music, and lots of React state management to complete the entire project. Have a look at it.